Constructor parameter. In Flutter, constructor parameters play a crucial role in creating customizable and reusable widgets, significantly enhancing the flexibility of application development. When defining a custom widget, developers can specify parameters in its constructor, allowing the widget to accept data that influences its behavior and appearance. This encapsulation of data enables a modular approach, where a single widget can adapt to different contexts based on the parameters provided. For instance, consider a simple custom button widget designed to display a label, change color, and execute a callback function when pressed. By defining parameters such as label, color, and onPressed in the constructor, developers can easily create multiple instances of this button with different configurations, all while maintaining a consistent underlying structure. Using named parameters in Flutter constructors adds clarity and readability to the code. Named parameters allow developers to specify values explicitly, reducing the likelihood of errors associated with positional arguments. For example, instead of providing parameters in a fixed order, one can instantiate the custom button like so: custom button, label, click me, color, colors.blue, onPressed, my callback. This approach not only makes the code easier to understand at a glance but also allows for default values for optional parameters, improving the overall usability of the widget. Furthermore, Flutter's null safety feature ensures that developers can enforce required parameters, leading to more robust and error-resistant code. Constructor parameters also support the concept of state management within widgets. For stateful widget, initial parameters can be used to set up the state of the widget, which can change over time based on user interaction or other events. For example, a profile card widget could take parameters such as username, profile picture URL, and bio. These parameters can initialize the state and dynamically update as the user interacts with the application, such as editing their profile. This dynamic behavior is crucial for creating responsive applications that provide real-time feedback to users, enhancing user engagement and satisfaction. Another significant advantage of using constructor parameters is the ease of testing. When writing unit tests for widgets, having clearly defined parameters allows developers to test various configurations and ensure that the widget behaves as expected under different scenarios. For example, one can easily create tests that validate how the custom button reacts when different labels or colors are passed, ensuring that it consistently renders and functions correctly. Moreover, constructor parameters facilitate better collaboration among developers. When building a library of reusable widgets, having well-defined parameters allows other developers to understand how to use the components effectively. Documentation can be created around these parameters, providing examples and usage guidelines that enhance the developer experience. This clarity is especially beneficial in larger teams where multiple developers may be working on various parts of the application. In summary, constructor parameters in Flutter are essential for building flexible, reusable, and maintainable widgets. They improve code clarity, enhance state management capabilities, support better testing practices, and foster collaboration among developers. Mastering the use of constructor parameters enables developers to create dynamic applications that can easily adapt to changing user needs, ultimately leading to a more efficient development process and a superior user experience. Weather API. Weather APIs have transformed the way developers access and utilize meteorological data, enabling the integration of real-time weather information into various applications. With the growing importance of weather data in everyday life affecting travel, outdoor activities, agriculture, and more, these APIs have become invaluable tools for developers. A weather API typically offers endpoints that provide current weather conditions, forecasts, historical data, and severe weather alerts, all of which can be crucial for enhancing user engagement and satisfaction. Popular options like OpenWeatherMap, Weather API, and AccuWeather API offer different features and data granularity, allowing developers to choose one that best suits their application's needs and target audience. The integration of a weather API generally begins with making HTTP requests to the API's endpoints, which usually return data in JSON format. This process allows developers to easily parse and manipulate the data to present it in a user-friendly way. For instance, a travel app can leverage a weather API to show users the current weather conditions at their chosen destination, thus enabling them to make informed decisions about their travel plans. The ability to deliver real-time weather updates can significantly enhance the value of an application, making it a go-to resource for users who want timely and relevant information. One of the key advantages of using a weather API is the capability to provide localized weather data. Many APIs allow developers to utilize geolocation services to fetch weather information based on the user's current location. This feature is particularly useful for applications focused on outdoor activities, such as hiking or biking, where weather conditions can have a substantial impact on safety and enjoyment. For example, an outdoor adventure app can alert users to impending storms or severe weather, helping them plan their activities more safely and effectively. Furthermore, weather APIs offer a rich set of data points beyond basic temperature and humidity readings. Many APIs provide additional metrics such as air quality index, UV index, and pollen counts, which can be especially beneficial for users with specific health concerns. By incorporating this data, developers can create applications that serve diverse user needs, from outdoor enthusiasts checking conditions to allergy sufferers monitoring pollen levels. Data accuracy and reliability are critical considerations when selecting a weather API. Developers must evaluate the sources of the data provided by the API, as the effectiveness of the application heavily relies on the quality of the information it presents. Some APIs aggregate data from multiple sources, while others may pull from national meteorological services. Understanding these nuances helps developers choose the most appropriate API for their specific use case, ensuring that users receive reliable and timely information. Moreover, integrating a weather API can open up monetization opportunities for developers. Applications can collaborate with local businesses or tourism boards to create partnerships, offering targeted promotions based on weather conditions. For instance, a weather app that predicts sunny days could partner with outdoor gear retailers to provide users with special offers on related products, creating a win-win scenario for both the app and the business. In conclusion, weather APIs are essential for developers looking to enhance their applications with real-time meteorological data. By offering localized and accurate weather information, these APIs empower developers to create applications that are not only informative but also highly relevant to users' immediate needs. As weather data becomes increasingly integral to various aspects of life, the ability to effectively leverage a weather API can significantly improve user engagement, satisfaction, and overall application value.
The end.